LC oscillations play a key role in learning alternating current chapter. L, as we know, it's a device. It can store energy. C is a capacitance, which is associated with a capacitor. C stands for capacitance. L stands for inductance. Both are properties of inductor and capacitor respectively. And what do you mean by oscillations? They exhibit electrical oscillations. They exhibit a frequency quantity. Let me start the first statement. A capacitor and inductor, capacitor is a device, inductor is a device, can store electrical, means capacitor stores energy in the electrical energy and inductor stores energy in the form of magnetic energy, means both are storage devices. Now when a charged capacitor, the statement is very simple. When a charged capacitor is connected to an inductor, uncharged inductor, the charge on the capacitor and the current in the circuit, means charge and the current in the circuit, exhibit the phenomenon of electrical oscillations, similar to the oscillation in mechanical systems, means charge is going to decrease, current is going to increase. Let a capacitor be a charged. Let I had a capacitor which is charged to Qm, that is the maximum charge at t equal to 0, and connected to an inductor as shown in the circuit. And the circuit shows that they were not completely closed, means the circuit is not closed. This diagram reflects you have a capacitor which is fully charged. The charge on the capacitor is Qm at t equal to 0. And what is the energy associated? The energy associated is given by energy in the capacitor is nothing but UE equal to Q square upon 2C. And what is the magnetic energy in the inductor? Inductor has no energy, hence it is called UB equal to 0. Yes, the circuit gives some information that you have a charged capacitor. The charge, maximum charge in the capacitor is Qm at t equal to 0, where capacitor and inductor are in the circuit, but it is not a closed circuit. It is called open circuit. Now, when the circuit is closed, so we'll have analysis. What is going to happen? When the circuit is completed, or the moment the circuit is completed, the charge on the capacitor starts decreasing, that is Qm starts decreasing, which gives rise to a current in the circuit. That is called Im. Slowly it becomes I, then it becomes I. Let Q and I be the charge and the current in the circuit at t equal to t, means at time t. At any time t, let Q be the charge and I be the current in the circuit. Now we'll have a mathematical learning process. So since current is increasing, that is di by dt is positive, current is increasing with time, the induced EMF in L, that is inductor, has a behavior that whenever current flows through inductor, there is an EMF, that is EMF is called induced EMF. That induced EMF is given by minus L di by dt. So hence whenever capacitor charge decreases, capacitor means when charge changes with time, that is called current. So what I mean to say, rate of flow of charges, that is Q by T, is a current. When the current flows in a circuit, that current through the inductor gives rise to induced EMF, that is given by mathematically minus L di by dt. So hence we'll have a polarity as shown in that diagram. Next, let me go to the next statement. So when that happens, according to Kirchhoff's loop rule, I need to put it a mathematical statement. What is a mathematical statement? The mathematical statement is the algebraic sum of the EMF plus the induced EMF in the circuit when you travel through a closed loop is 0. That is mathematically given by the charge across a capacitor, that is Q by C. Of course, sorry, it is called charge is Q, capacitance is C. The potential across a capacitor, that is charged capacitor, is given by charge upon capacitance Q by C. And the induced EMF is given by minus L di by dt, and that's what Kirchhoff's loop rule. After Kirchhoff's loop rule, what exactly is a mathematical simplification? So I is a current which is given by minus di by dt. In the present case, charge decreases, that is capacitor loses a charge, and inductor, in the sense current in the circuit increases. Yes, hence the energy in the inductor goes on increasing. Energy means magnetic energy. Of course, this mathematical relation, instead of in terms of di by dt, first derivative, let me replace in terms of a charge equation. Look at this, L comes in the, it becomes Q by LC minus di by dt. I'm going to replace with minus dq by dt. Hence the equation reduces to second order differential equation in charge. So what is this equation? That equation is very simple and meaningful. You can cross check. This equation q by c minus L di by dt, in place of di by dt, you go with dq by dt. It becomes second derivative d square q by dt square minus becomes plus. It is 1 upon LCQ. That is, simplification gives you a very simple rule, d square q by dt square plus 1 upon LCQ equal to 0. So what is the relationship? This equation has the form, means d square q by dt square resembles our second order differential equation for a oscillator, that is a simple pendulum equation, that is d square x by dt square. X is a displacement, omega is a frequency, angular frequency. The charge here displacement. The charge therefore oscillates with a natural frequency omega. Natural frequency, all of us know, I hope most of you remember, natural frequency is given by 1 upon under root LC, where a charge is going to vary. When the charge varies with respect to frequency, varies sinusoidal with time. Earlier we had a current, now charge is going to change with time. The change in the charge is given by charge equal to Qm, that is, charge at any instant is given by maximum charge, that is the maximum amplitude of a charge, cos function omega 0 t plus cos phi. Why it is cos function? You can think of it. So initially the capacitor is fully charged. When the capacitor is fully charged, if I put your angular frequency equal to 0, cross check uq equal to qm, because initially the capacitor is charged. Cos function means at phase angle something like a 0, the capacitor is fully charged. Hence we have taken q equal to qm cos of omega t. Let me go to the next mathematics, that is angular frequency. Natural frequency of a circuit is given by under root LC, where qm stands for the maximum value of charge and phi is a phase constant. It is a cosine function. As I explained, cosine function means cos 0 is 1. That's why charge is full. That's why q equal to qm at t equal to 0. The next relationship gives you some information. At t equal to 0, your charge is maximum, and we have a relationship followed. So what exactly this relation becomes? This relation equal to, when t equal to 0, q equal to phi m, your mathematical relation becomes q equal to qm cos of omega 0 t. So that earlier relation q equal to qm cos omega 0 t plus phi relation simplifies to at initial time, so it becomes charge equal to qm cos of omega t. Now what is the next relationship? We are interested in a current in the circuit, how current grows in the circuit. The current is minus dq by dt, which is given by, so I equal to Im sine of omega t. You differentiate cos, it becomes sine function, and you have simple mathematical relation. Now where Im stands for, again we all know it is omega 0 angular frequency, natural angular frequency into qm. Qm means a charge, omega 0 has a unit time, that is 1 upon time, hence I is nothing but charge upon time, that is called a current. To understand what exactly is a oscillation in terms of diagrammatic representation, we call it as, to visualize how this electrical oscillations takes place in the electrical circuit, consider a capacitor. We consider a capacitor with charge Qm connected to an ideal inductor. Ideal means it has no energy initially. Now, the whole circuit has energy. The energy in the circuit is only purely electrical in nature. That energy in the capacitor is given by half q square upon c. And at t equal to 0, since there is no current in the circuit, energy in the inductor is 0, means there is no energy in the circuit. Now, what is the initial energy of a circuit? The total energy is given by energy of a capacitor plus energy of an inductor. Inductor has no energy initially, t equal to 0, at t equal to 0. So total energy of LC circuit is purely electrical in nature. Hence total energy is given by U mathematically. U equal to electrical energy half Q square upon C. Now, this is the first diagram, that is UE. Capital U is given by U subscript E plus U subscript B. It is only electrical in nature, there is no magnetic energy. This circuit resembles this equation. The total energy of a circuit is this, and this is a time. The time is called t equal to 0. Now, after intermediate situation, we'll have, what is the intermediate situation? That is a time between t equal to 0 to t equal to t by 4, time t by 4. It is not t by 4. This is intermediate situation between 0, t, small t, time equal to 0 and t by 4. The slowly the charge decreases, current increases in a circuit, and the inductor gets current in the circuit. It is going to acquire energy. This is called L I square by 2. This is t equal to 0, small t equal to 0. This is small t equal to t by 4. At t by 4 time period, at quarter time period, that is t by 4, time period is capital T by 4, the whole capacitor has lost energy. Capacitor becomes completely drained out of energy. You will have only energy in the inductor that is stored in the form of magnetic energy, that is given by half Li square. I stands for current, L stands for inductance, and now there is no charge in a capacitor. This is at t equal to small t equal to t by 4. Now what happens to the next parameter? Let me make a simple angle in terms of statements. At t equal to 0, the switch is closed and the capacitor starts to discharge and the current increases, which sets up some magnetic field in the inductor, and thereby energy is stored in the inductor in the form of Li square by 2. So in the form of magnetic energy, which is written as UB, which is called energy stored in the inductor, which is in the form of magnet. Stored energy is always associated with the notation U. That is B means magnetic energy half Li square or Li square by 2. Now, as the current reaches its maximum value, that is Im, at t equal to t by 4, all the energy is stored in the form of magnetic field, which is half Li square. That's why the first diagram and the third diagram, in between it was an intermediate situation, t by 4. At t by 4, it becomes purely magnetic in nature. Now, what is this? Now again, slowly inductor starts losing energy. The arrow mark is reflected. Now this is now intermediate. Again, this small t becomes t by 2, again the inductor loses all its energy. It becomes purely, completely, the capacitor gets complete energy and it becomes complete electrical nature. Inductor again loses all its energy. This is the circuit for small t equal to t by 2, capital T by 2 time period. This is intermediate situation between t by 4 and t by 2. Now, one thing you need to notice, this is the plates of the capacitor gets reversed. Means the polarity of the plates are reversed. So that I will put it in this format. The current now starts charging the capacitor, means the energy stored in inductor loses energy and capacitor gains energy. So voice is not audible, Minas. Of course, uh, now at t equal to t by 4, the inductor is fully charged. Now inductor wants to give back because it cannot hold energy for a longer time because it's a dynamic state. Now the inductor starts losing current, means the current now starts charging the capacitor. This process continues till the capacitor is fully charged at t equal to t by 2. Means small t equal to 0, capacitor fully charged. At small t equal to t by 4, now completely inductor is charged. There is no energy in the capacitor. Now at again after t equal to t by 2, the cycle is progressing. As the processes, the current completely charges the capacitor. Now capacitor is fully charged, but the plates becomes oppositely polarity. In the sense, the capacitor has negative and positive, but it is charged. The capacitor gets fully charged with the polarity opposite to its initial state. What is the initial state? The upper plate was positive, the lower plate was negative. It becomes a reverse, minus minus in the upper plate, plus 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 in the below plate. Thus, the energy in the system oscillates between the capacitor and the beautiful inductor. Both capacitor and inductor exhibits oscillations. These oscillations are called electrical oscillations. And this is a beautiful diagram which is taken from Resnick and Halliday. You can cross check. Let me start here once again. Now, LC oscillations is electrical oscillations. Look at this first diagram. The first diagram is supported with inductor with no energy, capacitor with fully charged. Fully charged in the sense you have positive plate, you have a negative plate. Yes. Now, the total energy of a system, it is called inductor plus capacitor is called a system. The total energy of a system, it starts from A, the first diagram. The total energy of a circuit is purely electrical in nature. It is called magnetic energy is 0 in terms of a bar graph. So electrical energy is a blue. Yes. Now as t, this whole is small t equal to 0, this is again your intermediate state. What is the intermediate state? It is not t equal to any time. This is t equal to t by 4. And this is going to be t equal to t by 2. And this is going to be t equal to 3 by 4t. And this is back t equal to t, in the sense 0, t by 4, t by 2, 3 by 4t, and back to t equal to capital T. Let me start. The intermediate situation, what happens when capacitor starts losing charge, it starts decreasing a charge decreases, current grows in a circuit. That growth of current is given by I, which makes the inductor, current flows in inductor. You have a concept, whenever current flows in an inductor, there is, yes, rate of change of current gives rise to induced EMF. That induced EMF means it stores in the form of energy, that is called half Li square. So as time passes, at t equal to 0, the inductor was empty. At t equal to t by 4, 1/4 of a time period, the inductor gets fully charged. It is called fully magnetized. That's why now capacitor, nothing is shown in a visual diagram. So inductor is fully charged. It has full energy, that is called purely magnetic nature. So whole energy of a system at t by 4, time period t by 4, quarter time period, it is entirely magnetic energy. Initially it was electrical energy, it is now magnetic energy. Now again intermediate state between t by 4, time period t by 4 and t by 2. Look at the bar graph. Now it is purely magnetic in nature. There is no electrical energy. Now again what happens in an intermediate state, slowly the inductor starts losing energy. When the inductor starts losing energy, slowly the capacitor starts charging up. And now hence this is the intermediate state where the whole system is having both types of energy, magnetic energy plus electrical energy. All intermediate states, intermediate, 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 intermediate. During intermediate time period, that is t equal to time period intermediate, 0 to t by 4, t by 4 to t by 2, or t by 2 to 3 by 4t, or 3 by 4 to t, the capacitor and inductor both have some energy in the circuit, that is called energy is made up of electrical energy plus magnetic energy. Now, stopping at this point, at time period t by 2, that is half the time period, inductor has lost complete energy and again the capacitor is fully charged. It is called entirely electrical nature, but only the polarity of the capacitor is reversed. Then again the same thing continues. Now next, from moving from t by 2 time period to 3 by 4 t, again capacitor loses charge, it decreases its charge, inductor gets magnetized slowly, so again fully magnetized. What is the time? The time is 3 by 4 t. Here magnetized 3 by 4. And one thing you notice, the arrow marks here, it is inductor. It moves from it looks like I can say here it is looks like both. You can see it acts as a north and it acts as south. North side it enters, it ends here, and again the coil is in that fashion. Now here you can have opposite. The bottom becomes north and the upper becomes south, north to south, north. You can see the loop. The loop is visible. It reflects the idea. Now, when I consider this diagram at t by 2, do remember at t by 2 and 3 by 4t, the whole energy of a system is purely magnetic in nature. Now, again, intermediate situation, and finally I'm back with the same polarity. So, in a one complete cycle, the electrical energy is converted into magnetic energy into electrical energy, again electrical into magnetic energy, finally back to electrical energy. Means in one cycle, there are twice you will have the total energy becomes magnetic in nature and twice it is electrical in nature. And in the intermediate situation, there are four intermediate situations: 1, 2, 3, 4. Like the whole time period is divided into 4. T by 4, T by 2, 3 by 4t, and of course T equal to T. So once you look at the cycle, you can easily understand during LC oscillations, we come across energy in a system in terms of electrical energy, magnetic energy, as well as the combination of electrical and magnetic. You may have a multiple choice question in this fashion. At t equal to t by 2, I repeat, at t equal to t by 2, what will be the energy of a system? What is the energy of a system? So finally, let me conclude. At t equal to 0, it is electrical. At t by 4, it is purely magnetic in nature. And at t by 2 time period, it is purely electrical in nature. Again, but the plates are reversed. At 3 by 4t, it is purely magnetic. And finally, it is again electrical in nature. So t by 4 and 3 by 4t, it is purely magnetic. At time t equal to 0 and t equal to t by 2, it is purely electrical in nature. They are all called electrical oscillations.